Good afternoon. This is Ray Seifert. Today I'd like to give an introduction to using the EB program. EB is an integrated development environment designed to be easy for people to get used to. And I started this a few minutes ago. Google Hangout didn't allow me to do a screen share. It looks like it's going to work now. Yes. All right. Here we see the EB program, and it looks pretty plain. There are a lot of different dock windows and items on here, so I'd like to start by manipulating some of those. There's a view menu here, and with view you can tell it view and then click on a variety of different things like data, which is for high-level language, and view registers. If you're doing assembly language, you might like seeing registers. And you can adjust the size of these dock windows by sliding around these little separators. You can adjust the size of this one, the bottom, up or down. You can move them around. Let's bring in another one. Stack frame. And you'll notice stack frame is here. It's a tabbed window with registers. If I drag it, you can see right now register is kind of gray looking. Now there's a section above it. So I've successfully dragged it to be above registers. It's very convenient to have some of these stacked on top of each other. So if we do view terminal, if you're going to run a program and have it do any output, you might like seeing that output. It will be put in this terminal window. The ones that are on the bottom are just temporarily on the bottom. You can move them around to be on the side. You can move them to be on the right side. Well, I thought I had it on the right. All right, so now the terminal's on the right-hand side. You can move them to be separate from EB and then resize them independently. All right, or you can just move them back into one of these. I'm gonna leave it stacked. Now, there are a bunch of different toolbars up here. This first section is the file toolbar, and you can drag it to be on the left or the right or on the top. And it can be 2 rows on the top or 1 row on the top. All right. The next section is the edit toolbar. I don't really use these very much, but they're here. I use this one a lot because it's the execute toolbar. The green alien icon means run a program. This means to execute one statement of the program. This means to execute a statement and step into a function if it calls one. This one means continue. You can notice this one has an arrow that goes past a set of braces, and this one has an arrow that goes into a set of braces. So that's fine. This one is to stop the execution of the program. Over here we have a toolbar that has little pieces that can be clicked on to bring in some code. Let's start with the file menu up here, and you'll notice it says new and template. All right, let's do a template C++ program. All right, now we have a file name, and it's hello.cpp. And let's click on, all right, we got the terminal run. If we click on the green alien icon, it will compile the program and it executes it. And you'll notice we didn't step through it. In order to step into a program, we have to set a breakpoint. There are some tooltips that are possible. I have them turned off, and I'm going to turn them on. Now, if we go over here, click on a line number to set or reset a breakpoint. I don't have any tooltips for the edit window, though I had previously, and someone suggested that I not do that. Set a breakpoint. You can also just, I ended up clicking, I have a touchpad, and sometimes I get 2 clicks for the price of 1. All right, now if we click on the green alien icon to run, then it stops, and it actually stops on line 7, and you can see 7 is highlighted, and it's the next line to execute. The output is from the previous execution of the program. Here we see some data which we don't have a lot of value in right now. I'm assuming that people who are starting their introduction to EB have probably enrolled in like a beginning C++ class, and there's no point in getting into details about C++ today. But when we click on the next button, then it executes that statement, which makes it print hello world. And then we do the return 0, and it's basically trying to return from main. I'm going to click on the X button to tell it to stop. You'll also notice run can be done with F5, and next with F6, step F7, continue F8, and stop F9. So there's a collection of them. I use these buttons because I can't see the numbers on my keyboard without putting my glasses on. So the buttons are easier for me to see. All right, let's do a little bit more in here. Let's choose this thing which says int, an integer. All right, so it did int, and the idea here is to declare a variable. Let's say int x, and let's give x a value. X equals 5, and the compiler is not happy unless we do something like print x. So I'm going to put x on this line with the cout statement. And now we've got a variable declared called x. And you'll notice down here in the lower section, the data window, we have x, which it says is of type int, and its value is currently 0. We haven't done this assignment yet. When we do the statement, the value changes, and changed values are supposed to be displayed in red. This is some new code in EB, and it works fairly well. And I haven't distributed this in the Windows install exe format yet. I'd like to work on it a few more days and then distribute it. A few other things we can see here. argc is a parameter to the main function, and it has the value 1. And argv is a second parameter, and it's basically a collection of strings. So if we do put in the command line hello there and run it again, we can now see that argv has this string here, which is the name of the program. And we can scroll this, and it has hello and there are 3 parameters. You always have the name of your program as the first of the argv array, and then whatever would normally be on the command line. We're not actually using a command line, but I'm allowing you to enter these so you can develop command line programs. All right, so this part of the code over here has a bunch of different things in it. Like the first collection of them are little templates. Here's how you input something, like if you were trying to read a value for x. Well, if we were trying to read x, we would need to declare x before. So I'm going to do Control Z and get rid of that. And I think I'll get rid of the x equals 5 and tell it that I'd like to do a CN, and I'll do it below the declaration for x. And I'll put the x in here. So if we wanted to do an input, the CN means input, Cout means output. So now we can run the program, and it's not going to prompt if we don't tell it to, but we can execute the CN statement. And you'll notice we don't have another line ready to execute. We need to give it a number and press enter. And now it's ready to do the Cout statement. And you can see down below in the data window, we have 1, 2, 3, 1, 2, 3 for the value of x. If you're curious to know, I'm tired of these if you want to change it to a hexadecimal setup, that one is 1E0F3, and you can change it to be in a binary format. That's what it looks like as a binary number, although the bytes are kind of backwards, and this is the way they're stored in memory. All right. It's probably easier to view this as a decimal number. All right. So we were looking basically at the pieces that are here. This one gives you an if statement, and it's kind of crowded onto 2 lines there. I don't really want to have an if statement in the program, but I thought I'd just show what these do. And we've got another one that does an if with an else, a switch statement, which I'm not going to discuss, and 3 different kinds of loop statements, a declaration for a floating point number. So if you wanted to have a number that could be like 1.5 or something, you could do it that way, double Y. And we've got the ability to have strings. Let's see, Control Z. So if we want to declare a string, the way you do it is string and then a name for the variable. And we have below this, I'm going to wipe all this stuff out. If I do Control Z, it keeps track of a bunch of them, something like 100 different changes to the program. And I think that's probably enough to wipe it completely out. Well, maybe not. All right. There's always more than one way to do things. Shift and moving around lets you mark lines. So let's click on this one. Here we get a main program, but it doesn't have any Cout statements. This one gives you a function. This one gives you a class, and this one a struct, which we're not going to do. And the last item on this toolbar on the right is the library. And the library is intended to give a little bit more help than you can get from just inserting little snippets of code. So if you're trying to go to the top, we go to, and then to C++. Having troubles using my touchpad. All right. So if you wanted to declare an array or to work with an array, let's see, finding the minimum in an array. All right. This should bring up a web page, and it's not showing a web page here. Well, I must have killed this part of the program recently, and I will ignore it for now. I've been working with assembly recently, so I'm going to go to assembly instructions and see if these things have been preserved and not other stuff. Oh, yeah, so we have a problem with some of the C++ files at the moment, but I'll get them straightened out later. So if you're interested in assembly, I've tried to find the most useful of the instructions and give a little documentation inside the program. All right. Also in here, if you're looking at copying things, that one doesn't seem to be there. I'm going to switch to make sure that you're seeing that. You should be seeing that window. Yes. The flags register, Linux constants, binary constants. It's a lot of files that aren't working today. I don't have any clue why. I'm going to ignore that and kill these windows and go back to some more stuff that's kind of general purpose. All right. Going back to the view menu, we've got a couple of things in here that are not what you might expect. There's a toy box and a bit bucket. The toy box is more useful for C++ or Fortran or C, and it consists of two tables. You can choose Fortran from here for the language, but I'm going to leave it like it is. And here you can evaluate expressions. So if you pick the expression 7 plus 3 and you click do it, it tells you the result is 10. And this table will allow you to drag the sizes around. You can change that to a hexadecimal value. All right, you can change it to binary, and I'm not that interested in looking at it in binary, so I'll go back to just decimal. All right, and you can do things, have multiple expressions. You can use variables. Let's say you have the variable a and you declare it to be an integer and you use the value 5, and the value b is an integer and has the value 6. Then you can come down here and do a plus b. When you click do it, it builds a program to evaluate a plus b, compiles and executes the program and gets the result. We can have multiple expressions that we're evaluating. If we do a plus b and divide by 2, you can see that that gives us an integer result, and the result is 5. So that's kind of nice to know. If you want to get the remainder, the percent operator is the remainder operator, or the mod operator, and that tells us the remainder is 1. If you really wanted to get to 5.5, you need to have one of the values at least have a floating point value. So 2.0 makes it compute as a double, and you get 5.5. So this is very handy at the start of a C++ class, so you can evaluate expressions and get familiar with the format. Let's mess up the code here. A plus b, and we don't have the parentheses. Let's see how it's going to give us some stuff here. We get error in main, error expected parenthesis before semicolon. And you can see it saying dump. Unfortunately, the program that's being executed is called dump, and it really needs the parenthesis right there, and it's got a little caret symbol before the semicolon. You could put a parenthesis here and solve the nesting of parentheses, but you get a plus b, which is b divided by 2. What is b? B is 6. 6 divided by 2 is 3. A plus 3 is 5. So you have to worry about the priority of operations. If you want to divide a plus b by 2, you need to get the sum and then divide. And if you don't put parentheses, it's going to do it in the wrong order. All right. That's kind of handy. Very easy to get used to. The other little piece of the program is the bit bucket. I'm going to drag it down below also. See if I can shrink this part of the program. Well, I can make it go out front. All right. We've got a lot of different features in here. This is more likely to be useful for assembly language, and its purpose is to help you understand how numbers are stored in the computer and how it does a variety of operations. Right now we're in the tab of unary operators. Then there's a binary operator, integer conversions, integer math, float conversions. All right, so you get a handful of choices. With unary operators, there's not, negative, and a bitwise not. So let's do a not. Let's give it the value 1 and click on the not thing, and it says in the result column we got some bits that end in a 1, value converted to binary. Click on this again. Result as a binary bool. A bool takes 1 byte, and the not of a 1 is a 0. Let's see if this will allow us to use true. All right, a true converted to binary is a 1, and then doing the not of it gives you a 0. So let's try false. Click on that, we see false is a 0. Click on the not thing again, or exclamation point, and we get a 1. Technically, 0 and 1 are false and true. However, the way that C and also C++ works is you can use an integer as if it is a Boolean value, and if it's 0, it's false, and if it's non-zero, it's true. So we can put in addition to the number 1, we can put in like 6. Value converted to binary, and then do the not of it, and you get the value as a binary bool. All right, so let's do negative. Value converted to binary, all the bits flipped, add a 1, and 2's complement. I think that's the end of it. All right. So that's the way it stores the value -6 in binary notation. We can also use a binary format. So 0B1010 means a binary number. So if you want to see a binary number and then convert it to a negative, there you have it. And if we want to do the opposite pattern of doing a bitwise not of the number, the operator for that is the tilde operator. And convert the value to binary, we've already got a binary. And then you flip all the bits. So you can go through binary bit operators. So let's see, I don't want to do too many of those. How about an integer conversion? Decimal to binary. 125, convert it to binary. You divide it by 2 and take the remainder. And the result is the remainder at this point. So we got a 1. Click this again. We divide the 32 by 2 and we 62 by 2 and we get 31. Remainder is 0. So the next digit up is a 0. And I'm not going to explain exactly why this makes some sense, but this is the way you do it. You keep dividing by 2 and you build up bit by bit. So if you're taking a class where the teacher thinks it's worthwhile for you to know how to do these conversions, this might be handy. If you want to discover how a few operations work, I've got addition and multiplication. I didn't bother with subtraction and division, but I've got integer math. Float conversions, you can convert hex to float and float to hex. So let's do float to hex. I'm not going to explain how this works, but we'll have as our input 1.5 and click on the to float. And the bits that we have for the number at this point are these bits. You click it again, and we discover the sign bit is 0 because the number is a positive number. The exponent field is figured out. I'm not going to explain that. The exponent value, the fraction field, the binary value of the number is 1.1 times 2 to the 0, or just 1.1 binary, which means 1.5. Bit 23 is an understood bit, and we get that says float to hex, but it looks like it did the opposite thing. I need to check that out. Haven't done any tests of the bit bucket in months. All right. We can make these go away by clicking the little X in here. We can make them come out of their docked state by clicking the little icon next to that X. And this one, you might as well drug it. If you click that, it pops it back into its docked state. You can look at the stack frame. It's for assembly language, registers. There's a bunch more of things that can be viewed. There are not that many that are generally helpful. There's a backtrace, which is going back through the sequence of functions which have been called. We don't need a project today. I'm skipping that. And I think I'll skip tooltips. Now, you can save files, do a save as, you can change directory. And if you change directory, you can have different settings for your files or for your programs. The types of things you can do with the editor, you can comment and uncomment a set of marked lines, indent, unindent. You can find and replace, select all, select none. Prettify changes the layout of your code. It runs a program called A-Style, and you can edit settings. Probably you're not going to have much interest in changing the settings, though you could change like the columns in the data window, make it 32, and you'll see more stuff which might be useful if you're seeing it on the bottom. Save these. Now this is possibly wider, though it's not running a program right now. All right, we're seeing a hole in there, which is an error on my part. I have something which is still misbehaving. All right, so we have our main program which does nothing, and a function named f which is not called at all, but it's okay if you don't call a function. All right. Without teaching some programming, I might have a hard time thinking about things to do. Here's the indent function, which indents the current line if nothing is marked. That highlighted line is not the same as marked. You can indent a range of lines by marking them. Cut, copy, and paste, I think. That's to create a new file, I believe. We're not seeing the tooltips. Turn them off. New file, open, save, save as, close, new project, open a project, close a project, cut, copy, paste, undo, redo, indent, unindent. And there are more pieces in here than we could see. Increasing the font size. You can use this part of the program to increase the font size. And you'll notice it's increasing the fonts all over the place, but not in the title bar of the program. All of the stuff that is under control of the program is increased. You can also use a keyboard. A shift plus increases and a shift minus decreases the font size. So you don't have a lot of choice about which fonts to use, though you can go back to edit settings and let's see, we have choices of colors, but not of which font to use. Just cancel that. Oh, there's one more piece there that I didn't mention. I'll take my chances. French. All right. Right now, we're still seeing things in English. I'm going to exit from the program and tell it to save the program. And aha, now we have registers and floating point registers. Registers, ligne de commande, and données, data. That was the toy box. So if you would like to use a different language, it might work fairly well. I've had someone check the translations for Arabic, Chinese, English. Well, I checked English, French, and I can't remember if anyone checked these other language choices. It's possible. Spanish, I know several Spanish-speaking people. I should have had someone check it. I'm not too sure, but I'm in trouble if I don't stick with English. It's tempting, and I think I'll do it briefly. Save, exit. All right. I don't know what happened to that, but that's a little bit hard to read. All right. If you get all hosed up and you can't figure out what's going on, the file that contains the settings is called .eb.ini. So you can edit that file. The format of the file is fairly plain. There's a language. There are actually two languages in here. CPP, and then there is a language underscore name, which is English, and the code is EN. If you can remember your code for your language, you can change it. There's a lot of things you can change in here. And this one is to help somebody that's trying to edit and change the thing to use a different assembler. Lots of settings in there that are visible. We're back to the program, and I believe that this might be a fairly good spot for stopping on a first introduction to the program. Here where you can change the stuff, you got some help, moving in the file, etc. I'm back. I hope this made some sense, and I hope you get some time to try out EB and it works for you. Thank you. Goodbye.